In this video, we will solve these two logarithmic equations. For problem A, you have two logs with the same base on both sides of the equation. We can use this property that if you have two logs with the same base A equal to each other, then you can conclude that the two arguments must be equal because a logarithmic function is a one-to-one function. If the outputs are the same, the two inputs must be the same. We'll apply this property to the equation. So since the two logs are equal to each other with the same base 6, that means the two arguments, x squared plus 4x and negative x minus 5, must be equal to each other. So we can make the equation that x squared plus 4x equals negative 2x minus 5. Now we will solve this quadratic equation. To solve a quadratic equation, you want to make one side of the equation 0. So we will move everything to the left side. You will get x squared plus 6x plus 5. Now solve this equation by factoring. We want to find two numbers. They multiply to be 5 and they add up to be 6. So positive 5, positive 1. They multiply to be 5 and they add up to be 6. Here we can come up with two equations, either x plus 5 equals 0 or x plus 1 equals 0. So either x is negative 5 or x equals negative 1. Okay, these two are not the final solutions. Since this is a logarithmic equation, we need to check our answers. So what do we need to check? We want to check if the x we get here will make each argument positive in the original equation. In other words, we want to make sure x squared plus 4x is positive. Also, negative x minus 5 is positive because that is the domain for a logarithm. First, let's check for x equals negative 5. We'll plug it into each argument. So first argument, you have negative 5 squared plus 4 times negative 5. Wonder if it's positive. We need it to be positive. So it's 25 minus 20, which is 5, positive. Awesome. Now we have to check the other one. Well, plug negative 5 into the other argument. Negative 2 times negative 5 minus 5. Is it positive? Let's see. This is 10 minus 5, which is also 5. It is also positive. Since this negative 5 is making both argument positive, that means negative 5 is a solution. So I'm going to mark it here. Okay, negative 5 is a solution. Now we will check for x equals negative 1 to see if that is a solution. So check the first argument. Negative 1, plug in x squared plus 4 times x. So you have, here's 1 minus 4. Uh-oh, this is negative. So that means negative 1 is not a solution because it is not making the argument in the original equation positive, which means when x is equal to -1, this left logarithm is undefined. We can't have that as a solution. So we only have one solution here, which is -5. So the solution set only have one element in it, which is -5. So when we solve a logarithmic equation, you have to always check the x you get will make the original argument positive. Now let's look at the second problem. Log of 2x minus 7 equals to 2. This is different from the previous problem, because for the previous problem you have the case logs equals to another log, right? If they have the same base, then you can make the two argument equal. Well, for this problem, it's different. You only have the log expression on one side. On the other side, it's a number. So if you see this kind of problem, what you need to do is turn that logarithmic equation into an exponential equation. Okay, first let's find the base. Well, since it's log, that means it's base 10. Well, the base is 10. The exponent is this 2. 10 squared equals to, what's left is the argument, 2x minus 7. Okay, now solve this equation. 2 squared is 100 equals 2x minus 7. 107 equals 2x. Then x equals 107 over 2. Okay, since this is also a logarithmic equation, you should also check if this x is the solution. So check. So plug in 107 over 2 into the argument, which is this part, and see if our x is making that expression positive. Okay, so we'll have 2 times x is 107 over 2 minus 7. This is 2x minus 7, which is 107 minus 7. We have 100. It is positive. So we say, yes, this x is a solution. The solution set of this equation has one element in it, which is 107 over 2.